What is Gabriel's synthesis? Gabriel's synthesis is used for the synthesis of primary amines exclusively. In this reaction, the organic compound phthalimide with structure shown, an amide derivative, is used. Initially during this reaction, phthalimide reacts with potassium hydroxide and thereby forms potassium phthalimide, an ionic compound, along with water. It may be noticed that the compound phthalimide contains two electron withdrawing inductive groups or two -I groups. Due to -I effect of two carbonyl groups, the electron density over nitrogen of two neighboring carbon-nitrogen bonds is withdrawn towards it. This makes nitrogen electron deficient, which in turn withdraws the bonded electron pair of NH bond and thereby weakens it. Thus, the hydrogen ion can be easily removed, which makes phthalimide as a weak acid. Hence, strong base like hydroxide ion from potassium hydroxide removes acidic proton of phthalimide as water and thereby forms phthalimide. Here, the product potassium phthalimide ion is highly stable due to the presence of phthalimide ion having excess electron pairs on nitrogen. As the lone electron pairs on nitrogen is in conjugation with carbonyl group, by transferring electrons followed by CO bond transfer involves in resonance and thereby forms the resonance structure 2. The resonating structure contains a new carbon-nitrogen double bond. Similarly, the excess electrons on carbonyl oxide ion involves in resonance and forms another resonating structure. As phthalimide ion is resonance stabilized, it is highly stable and thus imparts stability to the entire product potassium phthalimide. In step 2, phthalimide ion, using its excess electrons, attacks the alkyl halide Rx via SN2 reaction, displaces halogen X as halide ion X- and thereby forms N-alkyl phthalimide. In this compound, a new carbon-nitrogen bond is formed. Finally, N-alkyl phthalimide on acid or base hydrolysis forms sodium phthalate along with primary amine. For example, when potassium phthalimide reacts with ethyl bromide, N-ethyl phthalimide is obtained. This compound having a new carbon-nitrogen bond on base hydrolysis forms ethanamine along with potassium phthalate.